We're asked to calculate the probability that 3 randomly selected people all have the same birthday. So let's just take one example to start off. Let's say January 1st, right? The probability that, let's assume everything's randomly distributed, random and uniformly distributed, which means every day has an equal chance of being a person's birthday. That's not the case in reality, but let's assume that's the case here. That means it's a 1 out of 365 chance that person A has January 1st as their birthday. But it's also a 1 out of 365 chance that person B has January 1st. And it's a 1 out of 365 chance that person C, the 3 people, have the same birthday. And I've written them next to each other with parentheses because we multiply these probabilities together. Because the law, actually, second guess myself, I don't know if it's a law, but the rule of independence in probability says that the probability of 2 or more events happening together can be calculated by multiplying their probabilities if they're independent. So in other words, like if the probability that it's going to rain today is 1/2, and the probability that I choose my blue shirt is a 1/3, and if I'm assured that, or knowing that rain's coming doesn't make me choose a blue shirt or a red shirt, so if they're independent of one another, the probability that both of them happen is 1/6, because you multiply them together. Okay, the probability that today it rains and I wear a blue shirt will be 1/2 times 1/3 makes 1/6. Same thing here. The probability that one person has January 1st is 1 out of 365. The probability that the other person has January 1st, assuming that they're independent, assuming that being born, that person A being born on January 1st doesn't affect person B being born on January 1st. That's also 1 out of 365. So we multiply them together, like the rain and blue shirt example. But that's just for January 1st, right? There are 365 different ways this can happen. So we got to multiply by 365 to account for that. Because January 2nd, January 3rd, etc. So this is the calculation we need for this problem. And if you do that with a calculator, which I did before I made this video, oops, it's off screen. I did 1 divided by 365 in my calculator. I'm going to copy. I'm going to multiply by that pasted value by the same thing. So there's our probability. That says 7.506. And now that says, I'll just round the decimal off there. That says e to the -6 power. That's scientific notation. That means times 10 to the -6 power. Okay? Or in other words, that's 0.00001, 2, 3, 4, 5, 6. Got to move that decimal 6 places because of the -6 exponent. 0, 0, 0. There's another 0 here. That's our probability. Now you'll notice I only did this twice, right? I did 1 out of 365 times itself. I didn't do it 3 times because these would just cross cancel. That made my life a little bit easier. Okay.